Ladies and gentlemen, thank you very much for joining me for another video. This is Mark Anderson from Kellogg Community College, and we're going to look today at some mixed fractions. These 6 problems here are going to talk about, we're going to talk about how to handle a mixed fraction, which is a fraction over a fraction. And I'm going to break this down into 3 steps. And I'm going to try to use different color for each of these steps. So for step number 1, we're going to use basic blue. And step number 1 is going to be to work on the first numerator, so the top of this fraction, which I will call also level 1 and level 2, since these fractions do have different levels there. So what we're going to do first is we're going to get the lowest common denominator of the first fraction and then do our addition or subtraction. Then we will switch over to a new color. Let's go to maybe a light blue or green in this case, and we're going to do the bottom part. We're going to get that lowest common denominator and then do addition or subtraction of that. And then with the third color, we're going to, let's go with a bright green here. The third color, we are going to then, after we get our common denominators for the top and bottom fraction and simplify those, we are going to skip, flip, and multiply. If you have been watching the videos here about the rationals I've been doing, this kind of covers multiplication and division of radicals. It covers getting common denominators with radicals to add. So these mixed, these complex fractions are fantastic to kind of review all of the different steps here. And to review again, we're going to get the lowest common denominator of this top fraction. And simplify that as much as possible. Then we're going to get the lowest common denominator of this bottom fraction in this complex fraction, and then simplify as much as possible. Then we will skip, flip, and multiply the 2 fractions together, and that will give us our end step. So let's go back to basic blue, and these little transitions will take a little time, but let's now focus on the top part of our fraction. Just focus on the 1 minus 5 over x. To get a common denominator between, because we can't just go 1 minus 5 over x, the 1 needs to have a common denominator of x. So I'm going to multiply the top number by x over x, and that's going to give me basically 1 times x, so x over x minus 5 over x, which I can simplify just to x minus 5 over x. And you're going to see me not write this step pretty much after this problem. So I'm just showing you why we're multiplying the top and bottom by the same thing to get the common denominator, and then we simplify that fraction. Okay, so now we have worked with the first piece there, and now what we're going to do is go and do the same thing with the bottom. You'll notice that the bottom fraction has, there's a 1 and then there's an x squared, so I need to get that 1 to have a common denominator of x squared. So I multiply the top and bottom by x squared, and now I have x squared minus 25 over x squared. And I can simplify that to x squared minus 25 over x squared. And so now I have these 2 fractions, and they're going to be divided by each other. And I'm going to show now in the third color that we haven't actually forgot that this is a complex fraction where there's one fraction over another fraction. So what I'm going to do is I'm going to now skip the first fraction, flip the second fraction, and multiply these 2 fractions together. I'm going to show this as, I'm going to rewrite my first fraction. Here's the top. I'm going to skip that fraction. I'm going to flip this second fraction, which is now going to have the x squared in the numerator and the x squared minus 25 on the denominator, and I'm going to multiply these together. As I said in the previous video, you now are allowed, when you multiply fractions, to cross-cancel or cross-simplify. So I will use a 4th color here. Let's see, in my palette, I better go with black on this one. And so I can now look at these cross pieces here. So what we will do here is we're going to do some, we'll look at this power of x and this x, and if I have x squared and x, that makes x to the first, x to the 0 power, which is 1, and this leaves me with just an x. This is factorable here, so this x plus 5, x minus 5 simplifies with this x minus 5 over here, which leaves me with an x in the numerator and an x plus 5 in the denominator. All right, so right there is the answer to that problem, fully simplified, x over x plus 5. And let's move on to the second one. And reset our colors here, using dark blue for the first fraction. So in problem number 2, our numerator, where we're going to work with the top here in dark blue, looks like we have a whole number 1, and we have an x plus 3. So we need that 1 to have a denominator of x plus 3. So I'm going to multiply it by this fancy 1 of x plus 3 over x plus 3. And so when I do so, I have x plus 3 over x plus 3 minus 6 over x plus 3. So then now I have my common denominator. You can see where I simplified my work quite a bit by just writing that over one denominator like that. And let's continue on with some simplification. X plus 3 minus 6 is the same as saying x minus 3 over x plus 3. So now what I'll do is move to a new color, the color for the denominator. I have 2 minus 12 over x plus 3. And what I'm going to do here is give this a fancy multiplication of 1. So this is going to be 2 times x plus 3 over x plus 3 minus 12 over x plus 3. So now I have a common denominator like this. So 2 times x plus 3 is 2x plus 6 minus 12. I'm doing a little simplification there. 2x plus 6 minus 12 is the same as saying 2x minus 6 over x plus 3. And now I switch to my green pen, and that green pen will allow me to skip, flip, and multiply. So I'm going to skip the blue fraction, flip the second fraction, and multiply it. And I'll rewrite that over here. So my x plus minus 3 and x plus 3 multiplied by my x plus 3 over 2x minus 6. So this bottom fraction just kind of loop-de-looped up to this right here. And now I'll use my black pen to show you how I can simplify or cancel these binomials. And you can only simplify or cancel if they're an exact match like that. And we can modify this one by factoring out a 2 to give me x minus 3, and then that simplifies with that, which leaves me with nothing in the numerator other than 1 times 1, which is 1, and in the denominator 1 times 2 times 1, which is 2. And so there's my final answer to problem number 2, 1/2. And that's kind of a sneaky problem if you take a look at the way that it was written and how those fractions, seemingly simplified to 1/2. All right, so let's go and take a look at 2 more problems here. Okay. And in this problem here, you'll see that we have a lot of symmetry between the numerator and the denominator. You can see that the numerator and the denominator both have this 2x plus 1. So what I'm going to do here is multiply this 5 by 2x plus 1. And if I do so like that, multiplying by that 1 of where the numerator and denominator is the same thing, I would draw a line beneath them, but it gets a little messy, as you can see by the pixelation there. I'm just going to multiply this by 5, so that's 10x plus 5 over 2x plus 1 minus 10 over 2x plus 1. And so I only write the denominator once, but I will now simplify the fraction, and by simplifying it, I'm going to go 10x, 5 minus 10. 5 minus 10 is negative 5. Okay, so now I'm going to go below. I'm going to go rock out a lighter blue here because the 2x minus 1 is my common denominator for this one as well. 2x plus 1, 2x plus 1, and I multiply that by 3. So now I have 6x plus 3 minus 18 over 2x plus 1. Do a little simplification here. Now I have 6x. I'm going to have minus 15 all over 2x plus 1. Oh shoot, I seemingly left that off of the other one. Let me go and change that back with my blue pen for that symmetry's sake. Okay, so now I'm on to my third step here using my green pen. Or, hold on. Boop, boop, boop. Okay, I'll go on to my green pen. Now I'm going to skip and flip and multiply here. Now what I'm going to do to save myself a little bit of time is I'm going to make that loop-de-loop there and multiply the dark blue by the green. So 2x plus 1 is over 6x minus 15. This is going to save me a little bit of time rewriting this whole thing over again, and I have my perfect match there and there. Now I have an answer of 10, and I'm sorry I didn't change that to black. I just kind of got carried away with the problem. And now I have 10x minus 5 and 6x minus 15. You might have an instructor or professor or teacher who wants you to keep factoring if possible, and you can factor out a 5, 2x minus 1. Here you can factor out a 3, so this is going to be 2x minus 3. And for a problem like this here, you cannot do any kind of 2x minus 5, excuse me. You cannot do any kind of simplification because 5 does not divide by 3 evenly. And also this 2x minus 1 and 2x minus 5 are not exactly the same. So there's nothing else to do. So some people would leave this as okay, and some would say go one step further, even though it doesn't simplify an extra step. So let's now go to problem number 4 of 6. My common denominator of the numerator is x squared, so this 1 is going to need an x squared. This second part is going to need an x, and then this last part is an x squared. So now I have x squared minus 12x plus 27 all over x squared. And what I'm not showing is that this is x squared over x squared minus 12x over x squared plus 27 over x squared. I'm just jumping right to that part where I get my common denominator. And if adding these rationals, if that's a problem, you should check out my earlier videos where I just do that, where I just go through the process of adding fractions together using variables like this. So here the common denominator is going to be x squared. So now I have x squared minus 9 over x squared because it's x squared over x squared minus 9 over x squared. Well, let's keep going on here. Green. For this step, again, I'm just going to kind of simplify by not rewriting the blue step here. I'm going to multiply by a flipped fraction of x squared minus 9. This time I think I will move on to the next color because we are going to get some simplification like that, where those divide and make 1. And also the x squared minus 9 is a difference of squares. And I know because I've done the problem several times today in class and also in these videos, I know that there is some magic to the simplification here. Pew pew! Those simplify, and what I'm left with in the numerator is x minus 9, and the denominator is x plus 3. Alright, so there's the fourth of the 6 problems here. That's as simplified as you can go. And so let's check out the next 2 here. Obviously, if you don't have these worksheets in front of you, it's good to pause the video and write these problems down, and that way you can work along with me. Okay, so problem number 5, common denominator is x squared. So here I'm going to multiply by 1 again, 1 that's filled with x squared over x squared. I'm going to multiply this by x over x, which is 1. So now my numerator is x squared over x squared minus 11x over x squared plus 30 over x squared, or like that, as one common denominator. Okay, moving on to my bottom half of this complex fraction. I'm going to multiply the top and bottom by x squared, and I'm going to multiply this top and bottom by x, and then the last one, nothing at all. So 1x squared over x squared minus 2x over x squared minus 15 over x squared is my common denominator. Alright, moving on to my third color, where I skip, flip, and multiply. These two are getting divided by each other, so I skip the first fraction, flip the second fraction, and multiply it like so. Alright, so there I have it. Using the fourth color to show my simplification step. And you'll see that actually this blue is now like flipped up here, so it's really not there anymore. So now let's do some simplification. The x squareds get simplified to 1. I'm going to do a little bit of factoring here to see if I can do any kind of more simplification, and I think life gets pretty good here. So what I'm going to do is find two numbers that multiply to make 30 and add to make negative 11. Find two numbers that multiply to make negative 5 and add to make negative 2. And the x minus 5 simplifies, so I'm left with, whoops, x minus 6 over x plus 3 is my final answer there. Alright, well, on to my last example here. So let's go and tackle it. On this complex fraction here, I have x minus 3x over x plus 3. And I'm going to keep thinking, like, shouldn't you change your color back? And I should change that back to blue. Okay, so I am going to now multiply this fraction by x plus 3 over x plus 3. So I want a common denominator of x plus 3, so I kind of not foil, but distribute that in there. So now I have an x squared plus 3x over x plus 3 minus 3x over x plus 3. And I'm going to move on to this next piece here, which is going to be my denominator of this fraction. So I'll note that I have this x over x plus 3 here, and so I need another x plus 3 in the denominator. So I'm going to distribute this as well. So this gives me x squared plus 3x over x plus 3. Doing a little bit of simplification work and the skip flip multiply step in the same stroke. This numerator here on level 1 is going to be x squared over x plus 3. I'm going to then skip flip multiply this upstairs so that x plus 3 is now in the numerator, and my denominator here is x squared plus 6x. Now let's get out our black pen, our final pen for the final problem for this worksheet video, and I'm going to do a little bit of simplification. Cross simplification or cross canceling can be done because they're perfect matches here, and this x squared cannot cross off this x squared here. In both of my classes today I had students who thought that was appropriate, but you can't because this is a binomial that's protected. In my previous videos I always considered them protected binomials so that you can't actually take a monomial and just cut it with this binomial or simplify it. So what I'm going to do is I'm going to factor out an x, and this x plus 6. Now I can take one of those x's away from the x squared, so now I have an x here over x plus 6. And this is my final answer, and again, all of this kind of stems back to the work that we've done before. Now if you're in my class, you'll note that we only did 6 of the 8 problems in this worksheet. In the second video, I'm going to show you some advanced tricks to solve these problems more quickly and efficiently, but it would require you to understand everything we've done so far. So the second video is definitely optional, but it is definitely for higher level work with this, to do a lot more fast and a lot more simplification mentally than on paper pencil. So again, thank you for watching today, but again, if you want to see the second video, it's part 2 of this series here on complex fractions that I've made. It's going to deal with some advanced techniques. So again, thank you for watching. I appreciate it.